Rolle's theorem. We start with a function f of x that starts at a and goes to b. We assume that it is continuous in that closed interval a to b. And by continuous we mean that it has no jumps. In other words, imagine if you draw this curve out with a pencil, but you can't lift that pencil up. That is what it means by continuous. And by closed interval, we mean that it includes the endpoints. Endpoint here, and endpoint here. Second, we assume that it is differentiable in the open interval a to b. By differentiable, we mean that it does not have sharp turns. Anywhere on this curve, it is not pointy, it is straight and smooth. And by open interval, we mean without the endpoints. So, this interior region highlighted yellow. Now, with these assumptions satisfied, the theorem states that if f of a equals f of b, meaning the points at the end align, then there exists a point C in the interior yellow region such that the derivative at C equals 0, or it is a horizontal slope. This is the theorem. We will lazy prove it. Now, by this visual alone, we can already see multiple locations of C where there are horizontal slopes, but this is not sufficient. We have to explore extreme cases. So one extreme case, given these assumptions, is a single maximum. But in this extreme case, there is still a single point C where the horizontal slope occurs at the maxima. Now, let's shift to the other extreme case where we have a minima. Now, similarly, a point C exists where the horizontal slope is at the minima. Now, let's take the final extreme, where we have no extrema. But now, since the first and last point were the same, this will just be a straight line. But if it is a straight line, then we have horizontals everywhere as we slide it across. So that is half of the proof by showing the extreme valid cases. But now, let's look at invalid cases. Now, imagine if it wasn't continuous, meaning it would jump. Here we see a jump at a point D. As we slide across, there's no point where we can get a horizontal slope. So this is a counterexample of if it is not continuous, meaning it jumps, then we cannot have a horizontal slope. Second, let's assume that instead of it not being continuous, let's say it is not completely differentiable, so there are sharp turns, as shown at D1 and D2. Again, if you slide across, there's no point where it is a horizontal slope. And with this second counterexample, we complete our proof for Rolle's theorem.